Hello guys, so we are back again, and in this session we are going to do some more questions on Lagrange method of undetermined variables. But before starting with the session, hope you have subscribed the channel so that we can bring more engineering content for you guys. And in the previous session we had completed two questions on based on Lagrange method of undetermined variables. We discussed how to form the Lagrange equation and all the basic things which were related to it. Now we are going to do some decent good level of questions on Lagrange, which will increase your understanding about Lagrange method of undetermined variables. So the first question which we are going to encounter is this: find the maximum value of 49 minus x square minus y square on the line x plus 3y equals to 10. Now you can directly make out that this is my phi and this is my f of x comma y, because they have to find the maximum value of this. When they tell you to find the maximum value of this or that, it is nothing but your f of x comma y. Here, since x and y terms are present in the function, so I will consider f of x comma y. Here in f of phi, x and y variables are there, so I am going to consider phi x comma y as. There is no z variable. Be cautious, okay, because don't do any silly mistake in the examination. And the second way to identify it is using the implicit function property, that phi x comma y is the implicit function, so it should be equal to 0. And here, since this function, if I move 10 to that side, it will become equal to 0, which is the left side. Now what we have to do, we have to, I know f of x comma y is equals to, you have to write here let, because they have not given you directly f of x comma y is this. So f of x comma y is nothing but 49 minus x square minus y square. Let phi x comma y equals to x minus 3y minus 10 equal to 0. You got these two things. Consider Lagrange function. What is the Lagrange function formula? L equals to f of x comma y plus lambda times phi x comma y. Just substitute the values and see what you're getting. 49 minus x square minus y square plus lambda times x plus 3y minus 10. Now stationary points we need to obtain. Stationary points are obtained. Stationary points are obtained by solving dou L by dou x equals to 0, dou L by dou y equal to 0, and dou L by dou lambda equal to 0. We are going to consider x and y. We are not going to consider z here because z is not there in the function. I'm telling it again, and because then only you will get an idea that why we don't need to write z here. So dou L by dou lambda equals to 0. We have written this. Now we want to get this dou L by dou x. How we will get it is minus 2x plus lambda equal to 0. Therefore x equals to lambda by 2. We can call it as 2. We will call this one as 1. Similarly, dou L by dou y is nothing but what it is, minus 2y plus 3 lambda equal to 0. From here we can get y, which is 3 lambda by 2, which is our third equation. Now dou L by dou lambda, which is nothing but x plus 3y minus 10 equal to 0, this thing only. So what I'm going to do, I'm going to solve it in the next page. Put x and y value in dou L by dou lambda equal to 0. Therefore what I'm going to do, we are going to put the values, which is lambda by 2 plus 3 into 3 lambda by 2, which minus 10 equal to 0, which will give you this will be lambda by 2, this will be 9 lambda by 2, and this will be minus 10 equal to 0. You can clearly see 10 lambda by 2 minus 10 equal to 0. If I move this, 10 cancel out. 5, okay, this will become 5. So Okay, lambda equals to 2, we got straightforwardly. Now what we can do, when lambda equals to 2, so x equals to lambda by 2, so it will be 2 by 2, which is nothing but 1, and y equals to 3 lambda by 2, so it is nothing but 3 into 2 by 2, which is nothing but 3. Therefore stationary point is 1, 3. Therefore f of 1, 3 is 49. 1 square minus 3 square equals to 49. 10. Okay, 49 minus, where we are putting this value? Here we are putting the values here in f of x comma y. 49 minus x square minus y square. If we put the values here, we are getting 39. Therefore maximum value of the function is 39. So in this question they needed to find us the maximum value, and we found it, which is nothing but 39. So now let's move on to the next question. This question was very similar to the previous question which we have taken. Hope you have understood each and every step. Now let's move on to the next question. The next question which we are going to take is this question. Here you can clearly make out that 3 variables are involved. Although they have written it here wrong, it should be f of x comma y comma z. Find the maximum and minimum value of the function f of x comma y comma z equals to x minus 2y plus 5z on the circle x square plus y square plus z square equals to 30 using the method of Lagrange multipliers. Now f of x comma y comma z is given x minus 2y plus 5z. Let phi x comma y comma z equals to x square plus y square plus z square minus 30 equal to 0. We know this. Now what we have to do? Consider the Lagrange function. The moment I consider it, what I am going to get? L equals to f of x comma y comma z plus lambda times phi x comma y comma z. If I substitute the value, x minus 2y plus 5z plus lambda times x square plus y square plus z square minus 30. This is what? This is 1. Now stationary point are obtained by solving what we need to solve. Dou L by dou x equals to 0, dou L by dou y equal to 0. Now here dou L by dou z will also come in picture because 3 variables are involved, and dou L by dou lambda equal to 0. Dou L by dou x is what? It is nothing but 1 plus 2x lambda equals to 0. Therefore we can get x equals to minus 1 by 2 lambda, which is our second equation. Dou L by dou y, which is nothing but minus 2 plus 2 lambda y. Therefore we can get y equals to 1 by lambda from here, which is third. And dou L by dou z, which is nothing but 5 plus 2 lambda z, right? Therefore z we can get here minus 5 by 2 lambda, which is our fourth equation. Now what we need to do is we need to get dou L by dou lambda. So dou L by dou lambda is nothing but, dou L by dou lambda is what? It is x square plus y square plus z square minus 30 equal to 0. So put x, y and z value from 2, 3 and 4. What we are going to get? We are going to get minus 1 by 2 lambda the whole square plus 1 by lambda the whole square plus minus 5 by 2 lambda the whole square minus 30 should be equal to 0, giving me 1 by 4 lambda square plus 1 by lambda square plus 25 by 4 lambda square minus 30 should be equal to 0. So what we are getting? We are getting something. If I multiply and divide by here by 4, then the denominator will become same. I will have 1 plus 4 plus 25 in the top, and here 4 lambda square minus 30 equal to 0. And you can see we are getting 30 by 4 lambda square equals to 30. Therefore lambda equals to plus minus 1 by 2. Now when lambda equals to 1 by 2, we have x equals to minus 1 upon 2 into lambda, which is 1 by 2. We are getting minus 1, and y is 1 by lambda, we are getting 2, and z is minus 5 by 2 lambda, which you can make out that minus 5 by 2 into 1 by 2 is nothing but minus 5. And when lambda is minus 1 by 2, we are getting x equals to minus 1 upon 2 into minus 1 by 2, which is nothing but you're simply directly 1, and y equals to 1 upon minus 1 by 2, which is nothing but minus 2, and in z, which is nothing but minus 5 by 2 into minus 1 by 2, which you can make out that it will be positive, and this time it will be 5 only. So stationary, here two stationary points we are getting. The first stationary points are, what are the stationary points? Minus 1 comma 2 comma minus 5, and 1 comma minus 2 comma 5. Therefore f of minus 1 2 comma minus 5 is what? Minus 1 minus 2 into 2 plus 5 into minus 5 equals to minus 1 minus 4 minus 25 is what it is? Minus 30. And f of 1 minus 2 5, it is nothing but 1 minus 2 into minus 2 plus 5 into 5, which is equals to 1 plus 4 plus 25 should be equals to what it is? 30. So we can make out, therefore maximum value of f of x comma y comma z is 30, and minimum value is minus 30. So we are done with this problem. Hope you have understood each and every step. Everything was similar, only just one extra term was involved here. Okay, so now let's move on to the next question. So the next question which we are going to consider is this question. Let me get the question. So here they are telling, find the minimum distance of the origin from the plane 3x plus 2y plus z minus 12 equal to 0. So this question is somewhat similar to the one question which we have solved in first order and second order derivative test. We have to consider point p comma y comma p x comma y comma z, because here a plane has three variables. We have to take the distance, and we want to minimize the distance, so our function will be the distance, which is under root x square plus y square plus z square, that I can directly make out, and this is our implicit function, that is phi x comma y comma z. So let's do it. Let p x comma y comma z be any point on plane. So its distance from origin is under root x square plus y square plus z square. Since we are doing here it with 0, so 0 minus x square, x the whole square, 0 minus y the whole square, and 0 minus z the whole square is nothing but under root x square plus y square plus z square. Here we need to minimize distance. So f of x comma y comma z is under root x square plus y square plus z square, and phi x comma y comma z, or constraint, okay, is 3x plus 2y plus z minus 12 equal to 0. Now consider the Lagrange function everything rest will be same only. L equals to f of x comma y comma z lambda times phi x comma y comma z. Substitute the values. Under root x square plus y square plus z square plus lambda times 3x plus 2y plus z minus 12. Therefore now stationary points are obtained by solving dou L by dou x equals to 0, dou L by dou y equal to 0, dou L by dou z equal to 0, and dou L by dou lambda equal to 0. Right, we have seen it. Now dou L by dou x is nothing but 2 times under root x square plus y square plus z square into twice x plus lambda times, this is what, 3. Okay, when we are doing it with this will be 3. So now let u equals to under root x square plus y square plus z square. So we could be easy to write it. It will be x upon u plus 3 lambda equal to 0. Now we can get x equals to minus 3 lambda u. Let's call it 2. Okay, now dou L by dou y is what? Dou L by dou y is what? 2y upon 2 under root x square plus y square plus z square into 2 lambda. Okay, so you can clearly make it equal to 0. Now this is our u, so it is what we are having here. It is, we are having y upon u plus 2 lambda equal to 0. So we are having y equals to finally minus 2 lambda u, which is our third equation. Similarly, dou z by dou L by dou z is nothing but z by u minus lambda. This you will directly make out since everything has been same only, equal to 0. We can directly get z equals to lambda u, which is our fourth equation. Now dou L by dou lambda equals to 3x plus 2y plus z minus 12 equal to 0. Therefore from 2, 3 and 4 we get, if we substitute the x, y and z value, we have 3 into minus 3 lambda u plus 2 into minus 2 lambda u plus minus lambda u minus 12 equal to 0. So minus 9 lambda u minus 4 lambda u minus lambda u minus 12 equal to 0. Therefore minus 14 lambda u equals to 12. Lambda u value we have minus 6 by 7. Why I am getting lambda u value? Because here lambda u and in x also lambda u was there. So we are going to substitute and get lambda x and y and z value. When lambda u is equals to minus 6 by 7, so x equals to what? X equals to minus 3 into minus 6 by 7 equals to 18 by 7, right? Y equals to minus 2 lambda u, which is nothing but minus 2 into minus 6 by 7, which is nothing but 12 by 7, and z is equals to lambda u, which is nothing but minus 6 by 7 only. So stationary point is what? 18 by 7, 12 by 7, minus 6 by 7. We got the stationary point. Now what we can do? Therefore minimum distance is what it will be, by putting the value in u, which is what? 18 by 7 the whole square plus 12 by 7 the whole square plus minus 6 by 7 the whole square. It is nothing but under root 72 by 7, right? Or okay, so we got our answer. So this was find the minimum distance of the origin from the plane. We have to consider point on the plane and then solve it. Everything was just same. Now in this session we have done 3 questions. You need to revise them properly and solve them again so that you understand the Lagrange method of multiple variables properly. And this is very interesting chapter. Okay, you can easily score good marks in this chapter. Just you need to identify how to use Lagrange method. So we are done with this session. See you in the next lecture. Thank you.